Hi everyone, welcome back. Today we're doing Excel sheet column number. So this question, I personally find it deceptively easy. It's actually quite tricky, especially under interview conditions. So for this question, this is tested by one of the tech companies in Singapore, pretty much within Shopee, ByteDance and stuff. So this question is pretty beneficial. So in this case, we're given a string column title that represents the column title as appears in an Excel sheet. And we have to return its corresponding column number. So for example, I'm pretty sure after so many project work and stuff that we did, these column numbers must jog some memory. So if you see A is the first column number, B is the second column, C is the third column. And if you see Z, then this will be the 26th column, because in the English alphanumerical table, I think A to Z, there's 26 permutations in the English alphabet. So understandably, if you have one alphabetical character, then you can represent 26 states. But if you throw in a 27th column, then Excel would have to use two alphanumerical characters to represent them. So when you see an AA, then this is 27. And if you see an AB, then this is 28. And if you see a ZY, then in this case, this is quite tricky. But how we would calculate it is 26, which corresponds to the number that Z represents, multiplied by 26. Because if you have seen Z, it means that you will have covered 26 full permutations of all alphanumeric characters. Just like how for A has the number 1. So if you see A in a column that has two characters, then the first A in this case would mean that we have already permutated 26 permutations. So that's pretty much the pattern. And if we have to break it down even further, the pattern is like this. So this would be 26 to the power of 1 plus 25 times 26 to the power of 0. So this is really the true pattern. And I would say perhaps the hardest part of this question is deciphering the pattern under interview conditions and only a few minutes to look at the question and understand it. But this is pretty much the pattern. So for this question, the column title would have a length from 1 to 7 characters inside this string over here. And the column title consists of only uppercase English letters. So that means we only have to handle A to Z and capital. And column title is in the range A to FXSHRXW. I mean, that's up to a certain number. So to tackle this question, since we were lucky to already find out what the pattern is, let's quickly break down this question into two parts. The first part is to convert each character into a given number, and given this number, we're able to use that function inside this pattern over here. And as you can see, the tricky bit is also on figuring out what is the power that we use for each of these characters over here. And personally for me, like the pattern that I have used is to iterate this string backwards. So by iterating the string backwards, the first character would have the index of 0, and the second character would have the index of 1. And subsequent characters on the left side would have a cumulative index of 2, 3, 4, 5 onwards to represent the number of full permutations of 26 characters that they have covered. And we will multiply that with the character number of that number instead. So that was a lot of words, and I hope that in the subsequent demonstration it will be clearer to our viewers over here. So with that, let's get started. The first step will be to convert the character to an integer, and this will take in a character and will return back an integer. So to convert a character into an integer, an uppercase character like this, let's say A should be mapped to 1 and Z should be mapped to 26. So to do this, we can use a built-in function called ORD. So odd in this case would give back a character's number inside the ASCII table. So as you can see, 65 is mapped to A. So we'll be using this pattern to implement this function. So to get the integer for a character, we can take the odd of the given character input, subtract it by the odd of capital A, and we add it by 1. So let's say if you have a character B, looking at the ASCII table, B is 66. So odd of B will be 66. And if you take odd of B minus odd of A, then this will be 65. And it will be 66 minus 65 plus 2, giving us 2, which is the number that we want. So B in this case would be mapped to 2. And this gives us the answer. So I hope this was clear. And we can start implementing the pattern that we have deciphered for getting the Excel sheet column number. So the first step would be to iterate through column title, but in reverse order from the right. And we'll be using that index as we iterate from right to left to indicate like how many full alphabetical suits of 26 permutations that this current character has went through. So let's do that in a bit. So let's call this character index, because this index points to the character that we want to look at the moment. We will also define a permutation index, and this permutation index represents the number of permutations that this current character has went through. So let's get started. So character index in range, we'll be starting off from the back of column title. So we will specify the final index in column title, which is the length of column title minus 1, since strings are 0 indexed in Python. We will permutate all the way to index 0. So we will specify -1 as the end of your iteration, and we'll be moving backwards. So we specify a step of -1. So once done, we can use this character index to get the current character that we have right now. So column title at this character index. And once we have this character, let's get the char int. So this char int would be char to int, and we'll pass in the char over here. And once we're done, we can use the current permutation index to represent the number of permutations that we have thus far. So if this is the first character, in other words, let's say zy, we'll be looking at y for in the first iteration, and we would say char int currently is equals to 25. And because this is the first character in this sequence, what this means is this y over here doesn't really represent any full permutations of 26 alphabets at the moment. So let's define a number. This number will represent the final column number. Actually, let's call this column number. And we will assign this to 0. Let's increment the column number by this pattern over here. So it will be char int, which is this number over here, multiplied by 26 to the power of permutation index. So represents the number of full permutations from A to Z by that character. So let's say in this case, if this was zy, y's permutation index will be 0, z's permutation index will be 1. Because for you to get z in the first for you to get the z in the first character over here, it means that you have passed through 26 multiplied by 26 permutations for you to even see this column string over here. So we're doing exactly that, and this looks fine. So this is pretty much the column number, and we can return this column number like this. So now that we have the algorithm, let's quickly test it out. So I will not be tracing this because we have traced it already, and thank goodness we extracted this so that it'll be easier for us doing tracing. So let's test this out with this test case, zy over here. So this answer, if I'm not mistaken, if you copy this and you paste it into Google, this should be 701. So let's, oh, actually the answer is on the bottom left, right? It's just right here. I shouldn't have done that. But anyway, let's try to see whether if we can get 701 with this approach. So permutation index will be equal to 0. Let's trace this out real quick. And the column number in this case will be starting off from 0. Character index will start off at length of column title. In this case, column title is equals to zy. So length column title will be 2. 2 minus 1 equals to 1. So character index will start at 1. The character at character index 1 will be y. So char is equals to y. And the character integer in this case for y will be 25. And the column number in this case will increment it by char int. So 25 multiplied by 26 to the power of 0. So to the power of 0, this whole thing just evaluates to 1. So we will just add 25 to our column number. So column number would just be 25. And now we're at the second index. Now we're pointing at z, which is also the final one. The character integer for z will be 26. And we'll be incrementing column number with 26 multiplied by 26 to the power of 1. So now, sorry, I forgot to, oh, thank goodness we traced. We actually forgot to increment permutation index by 1 after every iteration. So we will be adding column number by 26 to the power of 26. I think 26 multiplied by 26 is 676. I'm sorry, my math is quite bad. So now this gives us column number 701, and this is the answer. So let's run this against test cases. This pass, and let's submit this question. And there we go. So for this approach, if we represent n to be the length of column title, then in this case, the time complexity will be on. So time complexity will be on, because for every single character in the column title, we are iterating them from back to front. So that is pretty much a linear scan. The rest of the operations over here are pretty much O1, so we do not have to count them really. So that's pretty much it. For the space complexity, we use a constant number of variables, and each of these variables do not scale in memory with respect to n. So space in this case is O1. And that's pretty much it for this question. So this is a single pointer question, but even single pointer questions can be tricky if they involve some form of pattern recognition. So this, I guess, is kind of a, I guess it requires us, this kind of questions requires us to practice pretty extensively on pattern recognition questions to hopefully get such interview questions on the first try. So practice makes perfect, and I hope that this question and this demonstration was helpful for you. If you like this video, please give us a like and subscribe, and we will see you in the next video.